This is my mom. This is my dad. And this is me and my brother. Now, you may notice something very different between our parents and us. We have red hair.
I've lived with natural red hair my whole life, and due to the drastic difference between my mother and father's appearance and my own appearance, I'm frequently asked the same question.
Where does your red hair come from?
I've heard rumors within my family, but have never actually dug through my family history to find the source of my ginger hair. Thus, I figured it would be appropriate to do some investigating and share both the genetics of red hair and how I got mine. So first, let's dive into what exactly causes the red pigment in my hair.
Red hair is an autosomal recessive gene called MC1R that resides on the Q or long arm of chromosome 16. An autosomal gene is one that is not sex-linked, which means that statistically, an even amount of females and males should have the gene. A recessive trait occurs if one allele, a gene from either mom or dad, creates a broken protein that causes the recessive trait. If only one protein is faulty but the other is not, then the non-faulty protein will function and the recessive trait will not be expressed. However, if both proteins are faulty, then the recessive trait will be expressed due to the absence of functioning proteins. This means that a person with two broken MC1R gene codes will have red hair.
So, exactly how does the MC1R gene create faulty proteins that lead to red hair? Well, I'm glad you asked.
MC1R codes for a protein called the melanocortin-1 receptor. The receptor is primarily located on the surface of cells that produce the melanin pigment called melanocytes. Melanin is the substance that gives skin, hair, and eyes their color. There are two forms of melanin, and the amount of these pigments determine a person's skin and hair color. One of the two forms of melanin is called eumelanin. People who produce mostly eumelanin tend to have black or brown hair and darker skin that tans easily. Eumelanin also protects from skin damage caused by ultraviolet radiation in sunlight. The other form of melanin is called pheomelanin. People who produce mostly pheomelanin tend to have blonde or red hair, freckles, and light-colored skin that tans poorly. Pheomelanin does not protect the skin against ultraviolet radiation, which puts these people at risk of increased skin damage from sun exposure. The melanocortin-1 receptor controls which type of melanin is produced by melanocytes. When the receptor is activated, it triggers a series of chemical reactions inside the cell to stimulate cells to make eumelanin, causing darker pigments. If the MC1R gene is faulty, causing the receptor to be blocked or not activated, then the melanocytes produce pheomelanin instead of eumelanin.
And bam! Red hair! Additionally, polymorphisms or variations in the MC1R gene are associated with differences in skin and hair color.
This is why people with red hair frequently have fair skin, freckles, and an increased sensitivity to sun exposure. These polymorphisms reduce the ability of the melanocortin-1 receptor to activate eumelanin production, which, as stated before, then causes the melanocytes to produce mostly pheomelanin.
So, now that we know how red hair happens, where did I get mine from? Since we know that the red hair gene is recessive, both of my parents must be carriers, but how did it end up on both sides of my family?
First, I asked my mom and dad about the hair color of their siblings, and after confirming that none of my aunts and uncles were ever redheads, I decided to contact both my maternal grandparents and paternal grandmother to see what they knew on the subject.
My two sisters were strawberry blondes.
Was that all?
More red than blonde. My two older sisters.
Were either your parents redheads?
No. My father was bald.
What about, do you know if your grandparents were ever redheads?
I have no idea, but I doubt it.
I was told that I have a great aunt now, way back in in the Ukraine who had flaming red hair. And I don't believe that the flaming hair has to do with any kind of a temper, but she had a big temper. That's about it.
She was the only one that you know of?
Only one that I know of.
My grandfather, Lazard Gomelsky, they called it dark auburn hair. Now, he was already deceased before I was born. He died a year before I was born. And the pictures that I've seen of him, he had snow white hair, even though he was only in his early 50s. But he had the dark red hair in the family.
Was it just him? Did it stretch back any farther?
No one knew, or they didn't tell me, but all I know is that he had the dark red hair.
So, how come none of my aunts and uncles were redheads, but my brother, myself, and my cousin ended up as gingers? The recessive nature of the red hair gene causes it to skip generations, and this occurrence can be explained with a couple of Punnett squares.
Let's call the trait that does not cause red hair dominant allele capital R, and the trait that does cause red hair recessive allele little r. For this example, let's say parent 1 has the genotype big R, not a redhead and not a carrier, and parent 2 has the genotype big R, not a redhead but a carrier of the gene. 50% of their offspring would be carriers of the MC1R gene, but none of their offspring would have red hair. So continuing with this example, let's say one of parent 1 and 2's offspring, whose genotype is big R, has children with another person whose genotype is also big R. There's a 25% chance that these two will have a child with the genotype r, thus having a red-haired child. This is how red hair skips generations, and this process is demonstrated within my own family. Additionally, the probability of having one child with red hair and then the second child also having red hair are independent of each other, meaning one does not affect the other. The probability of a second child also having red hair is still 25% if both parents are carriers of the gene.
Thanks for coming on this journey with me as I discovered the history and the science behind my hair. Now I know what to say when the next time someone asks me where my red hair comes from, and knowing what I know now, I'd say my hair is pretty damn cool.